All right, so this lesson, Pre-Calculus 20, we are talking about multiplying and dividing rational expressions. So, last section, 6.1, we talked about simplifying rational expressions and just kind of working with individual rational expressions to factor, to divide out common factors, to note restrictions on variables. And so in 6.2, we're actually going to start getting into operations with rational expressions. Multiplying and dividing is 6.2. All right? So this is the textbook you have in front of you. What I want to do is I want to start off here in your notes with recalling how we multiply and divide fractions. Okay? So this is going to be very important to remember what we do when we multiply and divide regular fractions that are not polynomials, just numbers. So for example, 2/5 times 3/8. So I'm going to show you two different ways that we could do that, which will translate into what we're learning today. But what you could do, the very first thing you could do, is you could simply, when you multiply fractions, multiply straight across, right? So you could go 2 times 3 is 6, and 5 times 8 is 40. And that can be your first step. Now what you'd want to do, because that's your answer, but it's not simplified. So in simplifying the answer, you want to try and find a number that you can divide both the numerator and the denominator by, right, to reduce it. So we could divide both of these by 2, and we get 3 over 20. Is there another number that we can divide both 3 and 20 by to reduce it further? The answer is no. Okay? So that's method number 1 there. Multiply numerator times numerator over the multiplication of denominator times denominator, and then reduce the answer as much as you can. Okay, here's method 2. All right, so we might do something like this in method 2. You might say, okay, I'm going to, first of all, I am going to factor both the numerator and the denominator of each fraction. Okay, and what you could do for 8, you could split it up into its prime factors. Okay, now this is one of the things we're going to be doing with rational expressions, is we're going to be factoring rational expressions, our polynomials. So watch what this does. Okay, what you can do now is see that as a multiplication, this line is almost like it extends right across, and we have all of these multiplied together on top and all of these on the bottom. But before we actually get a big number, what you could do is you could divide out common factors, just like we did yesterday. And you could go directly from, this stage to the answer. Now we have 3 on top, and we have 5 times 2 times 2, which is 20. Now you might say, those are pretty much the same thing, Mr. Maxwell. Well, they're not. The first one involves reducing or factoring and then dividing out common factors first. The other one talks about taking out a common factor towards the end. Now dividing fractions is something that you may have forgotten a little bit about. What you want to remember for dividing fractions is you want to remember to flip and multiply. And I won't put a plus sign there. Flip and multiply. So that is something that we're going to keep in mind for today as well. So how you would solve this would you go, well, 4 over 16 times 8 over 3. Now you could do 2 methods here as well, and you could just go 4 times 8 is 32, and 16 times 3 is 48. And then you could reduce from here. You could divide both sides by what? By 8? Okay, someone said 8. Let's do that. What do we get? 32 divided by 8 is 4, and 48 divided by 8 is, no, not 8. What times 8 is 48? 6. Okay, so 8's a good choice. However, we can still reduce this further. So if that's the case, you have to look again, and we can divide both sides by 2. And that becomes what? 2 over 3. That's your final answer right there. Now, you could have saved yourself a little bit of work by dividing this fraction by what? Instead of 8, we could have divided by the largest common factor would have been 16, I guess. Okay? And that would have gotten you directly to here. Anyways, so to avoid this kind of thing, what we can do is probably a better idea would be to do that factoring, almost that method 2 first. So let me just erase this and show you that. So again, you want to flip and multiply. So the first step is to flip the second one only, not both of them. You flip the second fraction and then you can divide out common factors. So this 4 over 16 could reduce, but also look at this. This 8 and 16, and you could start kind of working like this. You could divide both sides by 8, and you could get something like this, a 1 there and a 2 there. And then you could say, well, are there any other pairs that I could simplify? Yes. The 4 and the 2, that becomes a 2 over a 1. And so when we do this, you can actually just get right to the answer, 2 over 3. And if you know how to factor and divide out common factors, that may be easier. So that's what we can do with just regular old fractions. So let's see, how does that translate with rationals? So I would encourage you to write this example down. And I do have the steps on the side here, okay? So we'll take a look at these steps as we move through. These would be good for your notes as well. So as we do this, you can jot down each of the steps. All right, so this is a bit of a more complicated example. We have a couple things going on here. We have rational functions, we have polynomials, numerator, denominator. We also have a division here instead of multiplication. So what you might want to do is do that flip and multiply thing as you factor. You can do these both in the same step. So the first step says to factor. So let's split all the steps up. So x minus 3 cannot be factored any further. X squared minus 9, though, that's a difference of squares. And so you have x plus 3 times x minus 3. Very good. So let's keep the division for now, and let's factor the second one. Well, you know what? That's already, the numerator and the denominator are already factored, so you don't have to do anything there. Now, let's show as multiplication. That would be the step 2. So this might be a little tedious to rewrite some stuff down, but don't be afraid of recopying things that you're not really working with, because trust me, once you get used to writing these down, it goes real quick. And when you can see all of this stuff together, you focus on one thing at a time, you make fewer mistakes. Trust me on that. So we write it as multiplication. Now, noting restrictions, and this is actually one of our first major differences here, noting restrictions. When you divide, okay, there are two things you need to consider. We cannot divide by 0. That's the big thing. But we also cannot have a denominator that, a denominator that's 0, which is actually not the same thing. So what I mean by that is this. When noting restrictions, I have to focus on this, the denominator of any fraction cannot be 0. I have to focus on those factors and this factor, true. Look at the original question though. I have to focus on this, which I've already outlined down here, and I have to focus on this whole thing, you see, because I cannot divide by 0. So what does that mean? Well, that means I have to focus on the x and the x plus 3. So the one difference is this. You have to also focus on the numerator here once you kind of change that into multiplication. So there's restrictions on each of these 3 parts in this example. So x cannot equal, right, from this factor, negative 3. From this factor, positive 3. So I'm just going to write it as positive plus or minus 3. Over here, this one cannot equal negative 3. I've already got that down. And for this factor, x cannot equal 0. All right? So you want to note your restrictions, but please note that it's, yes, the denominators, but also you cannot divide by 0. So that means this can't be 0 either, nor can this be 0. Okay? So just remember that. That's one different thing. Okay, now we can keep going and we can divide out common factors. So I will just quickly recopy this so I can make kind of new scratches on this for you. So this is what we have, x plus 3 over x. So dividing out common factors means from the numerator to the denominator, we can do some dividing out. We cannot divide out any factors that are across from each other. Make sure you don't do that. You can't say, oh, I have an x minus 3 and an x minus 3 both on top. Let's get rid of them. Only top and bottom, okay? Only top and bottom. So those are gone. Also, this is gone, okay?
So 1.
Does that look okay? Does that look right? So what I have here is a 1 over x. That's what I have left. Okay. And so what you want to do is you want to divide out, okay, express the answer, simplified expression with restrictions. So x cannot equal plus or minus 3 or 0. And that's your simplified answer there. All right. So let's move to our next example here. Express each product in simplest form. Well, so we're going to do the multiplication dividing. We're going to divide out common factors. We're going to note our restrictions as well. So let's just choose one of these. I'm going to do B with you here. Okay, let's do B. We've got multiple variables here. That's no problem. So let's factor. The top looks like this. Y plus 3 times y minus 3, because it's a difference of squares. Let's see. On the bottom, I'm going to take out an r, and I'll be left with r squared minus 1. And this is a multiplication, so you don't have to flip anything. Okay, I'm going to do this as well, factor this one. Whoops, I apologize, that's an r squared, I guess, isn't it? So that's r minus 1. See that? That's a squared, and this is a cubed. And then down here I have y plus 3. Cannot be factored any further. All right, so the original question was a multiplication, so as far as restrictions go, I only need to focus on this and this. Okay, just those two. So restrictions, x cannot equal. Well, it cannot equal 0 for this one. You know what I'm seeing here? I'm seeing that we could factor this further. It might be a little bit easier when we do restrictions to factor this further. So I'm just going to save space. I am going to factor this. I'm just going to erase this, and I'm going to factor it right here. So that r squared minus 1 is a difference of squares again. So this is actually r plus 1 and r minus 1. Okay? So if we go back to our restrictions, then r cannot equal plus or minus 1 as well for this one and this one. And of course, finally, x, I guess that's, what am I doing here? X, I should have said this is r. I'm just defaulting to x. That's r, right? R. This one is a y. So we have to also say, my goodness, we have to also say, hey, there's a restriction on the y variable as well. You see how y is different there? So y cannot equal negative 3. So if you have two different variables, you have to consider the restrictions on each variable. Okay, so r cannot equal 0, r cannot equal positive negative 1, y cannot equal negative 3. Everyone with me on that?
Yeah.
You got any questions? I can pause and answer questions if you want. No? Good? We're okay? So that's restrictions. All right, so now let's divide out any common factors that we might have. So I'm looking over here and I'm seeing an r here and an r there. Top, bottom. Those are gone. I'm seeing an r minus 1 with an r minus 1. That's gone. I'm seeing a y plus 3 and a y plus 3. Anyone else seeing that? Yeah? Okay. Anything else that can be simplified there? No, I think we might be good.
Yeah.
So we have a y minus 3 on top, and I'm still left down here with an r plus 1. And of course, with these restrictions as part of your final answer there. Okay? Okay? So how does that look? Does that, everyone agree with that? Did we make any mistakes there? You can see? All right, so just as we continue, got I think one or two more examples here. But I just wanted to make sure that we understood here, and I've already kind of covered this already in the lesson, but the restrictions here, when you're talking about division, right, what you have to do is you have to say, well, let's go with this second. This method one here, common denominator, I don't usually do this one at all. You can look at it if you want to know more about it later. We can talk about that. I don't usually require this sort of method at all. Multiplying by reciprocal is the one that I think is probably best. So anyway, so remember when you're dividing, you have to consider restrictions here and here, of course, but also here, because when we turn it into a multiplication, this x comes into the denominator. So we have to consider the restrictions on each of these three. So that's why they're saying y is x equals 0 a restriction, because it's going to be in the denominator when you flip and multiply. Okay? All right. Okay, so let's do another example. Now again, you should be kind of getting pretty good at this, but I'll do one more with you together so we can do this. Now, this is a difference of squares on top, so let's factor x plus 2 times x minus 2 on top there. We have a common factor of x in here, so let's take an x out of there. And we're left with x minus 4. Now, I don't mind if you go ahead and flip at the same time as you factor. I'm totally fine with that, so you can save yourself a little bit of a step. So I'm going to flip this one, and so I'm looking at this is going to be on top. So what's the factored version of this trinomial? Well, we need two numbers that multiply to negative 20 and add up to positive 1. So that's going to be x plus, it's going to be plus 5 actually, yeah, and then minus 4. Because 5 times negative 4 is negative 20, and positive 5 minus 4 is positive 1. Okay, and then down here, we're going to have what? Well, this is going to be, it says multiply to negative 6 and add up to positive 1. So that's going to be a plus 3 and an x minus 2 down there. Okay, so we're at this point, we have to note restrictions, and of course we have to note restrictions here, here, and here. Okay, at this point, and again, you guys should have these steps in front of you, right? Factor, shows multiplication, note restrictions. That's where we're at. So those three pieces there. So what's that going to be? I'll just put that off to the side here. So x cannot equal, well, if we focus on this factor, can equal 0. We focus on this factor, what makes this factor 0? A positive 4. Okay. Over here, what makes this factor 0? A negative 3. What makes this factor 0? A positive 2. Up here now, what makes this factor 0? A negative 5. And what makes this factor 0? A positive 4, which we've already mentioned. Okay? So any questions about that? Noting restrictions there? That seems a bit odd that we're noting restrictions in the numerator, right? But you understand why? Can't divide by 0 at all. Okay? All right, so let's move on. Haven't got too much left here. This is pretty straightforward now. So now we take a look at dividing off common factors, and I see an x minus 4 there, right? I see, what else do I see? An x minus 2 and an x minus 2 there. So those are gone. Can't quite see that yellow cursor, that's why it's a mess. Anything else? Okay, here's a question for you. Here's a question. Can I do this? I see an x up top with this x on the bottom. Can I divide those off? No. I see you shaking your head. No. The reason why is you can't pick a piece of a factor and take it out. You can only choose entire factors. So no, we cannot get rid of any x's like that. Okay. So anything else though? Okay, looks pretty clean. All right. So our answer then is x plus 2 on top. Remember, when these divide out, they're just ones, right? 1 over 1. It becomes 1 over 1. It doesn't become 0 or anything. It becomes a 1. So we've got x plus 2 times x plus 5. Boys, quiet please. And on the bottom we have an x still left and an x plus 3, right? Okay, so you can see there's no common factors. We'll also include our restrictions that we noted here. Rewrite them if you must. And those are in the final answer as well. Okay, so just double checking, make sure we've got everything. We flipped and multiplied, we factored correctly, noted our restrictions, divided things out correctly. Any questions on that? Okay, so the question is, why am I not noting restrictions on this right here? Okay, normally we don't, like 0 can exist in the numerator of a fraction, that's on top. 0 divided by any number is 0. Any number divided by 0 though is a problem. That is algebraically disallowed, okay? So we can't divide by 0, but we can have 0 on top. So 0 divided by anything that's a regular number, not 0, is 0. So this one, there's no restrictions here. X can be absolutely anything. But X cannot be certain values for these factors. And X cannot be certain values for these factors or these factors. The X values that cause this to be 0 would make this entire thing 0. And you cannot divide by an entire thing of 0. And this would be 0 in the denominator of this particular fraction, or rational, so that's not allowed. So we'll leave this one alone up top here, no restrictions there. Okay? Good question. All right, I'm going to give you a couple minutes to see if you can do this one now. So I will give you one hint, though. You're still going to have to factor. You're still going to have to note restrictions. But when you show as multiplication, you only have to flip this one, not this one as well. You don't have to flip everything that comes after the divided sign. You only have to flip this one. Okay? Flip and multiply. So take a couple minutes, take 2 or 3 minutes, whatever you think you might, well, I'll give you 2 or 3 minutes, and see if you can simplify that and note the restrictions, and I will show you the answer in a few minutes. Okay, so hopefully you've all had a chance to take a look at this. Yes, you probably found that the answer is in your textbook. The solution is in your textbook. Some of you found that out, I see. But again, if you follow the steps and follow the rules, we are factoring. You can write as multiplication right away. Note your restrictions. And again, the restrictions are going to be found here. And here, and here. Now there's no x in here, right? So there's no restrictions associated with 6. Doesn't matter what x is, 6 will never be 0. Okay, and then there's no restrictions in the denominator. There's no denominator here with x either. So you're looking at the restrictions in these areas right here. So that's where you get these as restrictions here. So your final answer here should be -3 over m, with m not equaling, or not able to be equal. The restrictions are plus or minus 3 over 2, and 0 and 5. All right? How many of you were able to do that one on your own? Anybody? Okay, not too many. All right. All right. Well, that's one of the more challenging ones for this section, but yeah, so if you were able to kind of get most of the way through that. So again, factoring is a big deal. If you're not good at factoring trinomials, you need to get better at that. So come talk to me, watch some other videos that I have. FM10, factoring trinomials, look up those videos if you want. You'll need to get practice with that. Okay, so there was a question here, good one, about this part right here. Let me zoom in for you. So about this part right here. Now remember, and I believe we talked about this last lesson, if you have 2m minus 3 and 3 minus 2m, if you have the same terms in a binomial subtracted, but then you have another binomial that's the same terms but flipped around this way, then what you can do is treat this as a, you can factor a negative out and then they become the same. So this is what I had here. I had 2m, oh my goodness. I had 2m, let me just see if I can get back to where I was. So I had 2m minus 3 down here, and I had 3 minus 2m. Almost the same. I can divide these out as long as I show that I have a -1 as a factor. Now, so just explaining that even a little bit further, right, would be this. If I took a -1 out of 3 minus 2m, then that actually becomes -3 plus 2m, which is the same as this, 2m minus 3. So now that 2m minus 3 down here and this 3 minus 2m becomes the same as long as I factor out a negative. Okay, so that's a little extension of what we did last day there. Okay, good question though. Anybody else? Any questions about what happened here? Yeah. Okay. So what I'll need you to do is to read through the key ideas, please. Take a few moments and read through those. And then I'll give you the assignment for today. Yeah, there's not that many. Well, there's ABC for most of them. But anyways, yeah. So in the textbook here, this is what the questions look like here. Oops. The more practice you get, the better you'll be at it, and the quicker it'll go. So it's 1, 2, 4, 8, and 15. Okay, so for number 1, just to get you going, again, 12 can be reduced with 4 here. So this, if you divide both by 4, you get 3 up here and you get a 1 here, right? 15 and 5 can also be reduced. So that's going to be a 1 if you divide both sides by 5, and this is going to be a 3. What about the m's? We've got m squared up here and an m on the bottom. So one of those m's goes with one of those m's. The C and the C completely divide out, and the F and the F completely divide out. So it's a bit of a mess there, but what this translates into is 3 times M times 3, so that's going to be 9M on the top. And on the bottom we have a 1 times a 1. They're all just 1s on there, so 9M over 1. Does that look like 9M? Now the non-permissible values then, let's erase all this. So the non-permissible values, C cannot equal 0, F cannot equal 0, and M cannot equal 0. So nothing in the denominator, for as far as variables go, can equal 0. Okay, is that the correct answer there? I didn't miss anything? Anybody else get that? Okay, for B, I'll do B as well for you right down here. And B is, like I say, pretty easy because they've factored these trinomials for you and these expressions, so you don't have to do any factoring in this one. You just have to notice any terms that are the same. So A minus B on top and A minus B on the bottom. We have an A plus 5 on the top and bottom. And then, of course, the 3 and the 15 can be reduced. You divide them both by 3 and you get 1 over 5. Okay. So remember, you cannot do this. Please don't do this. Hey, there's an A there and an A there because students are still doing this. Say some of you are still doing this, so please don't do this. You cannot do that. So what we're left with here then is this. We've got 1 times A minus 5. Okay, so we just have A minus 5 on top. And we have A minus 1 and with 5 on the bottom. So 5 times A minus 1. Restrictions, A cannot equal positive 1 here. A cannot equal negative 5 here. And A cannot equal B. Very good. Okay? So, and also if you want to put B as well, B cannot equal A. And that's because if these were the same, then it would be something minus itself, right? So A cannot equal B, and B cannot equal A. Okay, that's how you get started on question 1.